Hey guys, how you doing? So, a lot of my projects are soft robots that need some form of an air source. Usually I just show them being used with a syringe or squeeze bulb. But what if you want to autonomously control a soft robot? That's where this little box comes in. This is the Aerobox. The Aerobox contains a microcontroller, a driver chip, an air pump, a solenoid valve, and a battery. This means you can autonomously inflate and deflate air pockets within a compact, battery-powered system. Let's go over what you'll need to build it. As for materials, you'll need one 5-volt Adafruit trinket, one L29 3D driver chip, a small diaphragm pump, a small solenoid valve, a 9-volt battery clip, a small slide switch, a 5-volt buck converter, a piece of perf board, 1/4-inch neodymium magnets, some wire, some solder, an 1/8-inch tubing, and a Y connector. I'll have the links for all of these in the Instructables guide. For tools, you'll need access to a 3D printer, a soldering iron, a hacksaw, a vise for soldering and sawing, flush snips, wire strippers, super glue, and a computer with the Arduino IDE. Start by soldering headers to the trinket and arranging everything on the perf board as it's shown in the pictures. Then, solder the trinket and the driver chip in and solder the proper wires to connect them accordingly. Take the battery clip, cut off the barrel plug, and strip the ends. Solder a switch into the middle of the red wire, then solder the ends of the clips to the proper pins. Cut 1/2-inch pieces of the 1/8-inch tubing and connect the pump to one of them and the valve to the other one. Connect both up to the short legs of the Y connector. Now you can solder them onto the board, making sure that the pump and valve can fit flat against the driver and trinket. In order to power it off of a 9-volt battery, we need to implement a buck converter. Cut the red wire and the black wire of the battery clip before the switch. Solder the converter in and make sure it's facing the right direction. I didn't do this at first and fried my trinket. Speaking of which, now's a good time to test if it works. If all goes well, the valve and pump should work. Next, we need to trim the board. Mark out a rectangle on the perf board with the dimensions of 58mm by 55mm. Use a hacksaw to cut this part out. Now to 3D print the case. I printed the two parts on medium resolution with 5% infill and PLA. Once the case is printed, put a bit of super glue in the holes for the magnets and insert them. Make sure they're facing the right way. Snap a 9-volt battery into the clip and slide the board, battery, and pneumatics into the case and fit the switch into the slot. Magnet the cover on and you're done with the hardware. To use it, connect tubing to the third port on the Y connector and have that connect to your soft robot. Then you can load up code onto the trinket using the programming guide I've included in the Instructables guide. Now, you may be wondering, if it only has one air output, is it actually that useful and practical? The answer is yes. Most soft robots out there in the community, including many of my own, only require one input. This makes it perfect for actuators and grippers. I will also be using this in an upcoming project where I will be combining a soft robotic gripper with a hard robotic arm. Anyways, make sure you don't miss that upcoming project by clicking that subscribe button. If you want to build your very own Aerobox, check out the Instructables and Hackaday.io pages that are in the description. If you like this video, then you know what to do. XYZ Aiden,